Hi everyone, welcome back. My name is Pravanjan Chaudhary. I'm CTO of Capillary Technologies and building a new venture named Assets.Cloud. For those of you joined later, this is the second part of the talk today, where I will share some tips and tricks that we used in Capillary, which is correlating to the first conversations uh, where I shared some principles that we used in Capillary, and now we'll show some tips and tricks of how to achieve them. Again, a quick recap for who joined late about us. We're Capillary Technologies with 5 products in loyalty, engage, insights, commerce, and smart store. We're SaaS, B2B, and architecture is primarily multi-tenant with real-time systems, data platforms, data science workloads, commerce transactions, etc. We have deployed at deployed at about 11 global regions of AWS and a few $1 million of cloud spent per year. We spoke about attribution and governance in the first discussion, where we spoke about how governance attribution is a key prerequisite for governance, where we attribute not just to cloud assets, but to P&Ls, to product teams, to product groups, to even customers and business metrics. And the eventual goal is to tie up the cost to a business metric that essentially can be a North Star for all the teams for optimization. Now let's look at how to achieve that. A simpler term is to call tagging, which is essentially all of you would be aware of that how we can tag, but the whole idea is to tag the cloud resources much more intentionally, right? So, of breaking it down by these and decentralized attribution that you want to do eventually. So, like taking a simpler example here, where the total server cost can be first broken down by P&L wise, R&D and business, and then the business or the prod can be broken down by products, and then the products can be broken down by teams and different teams. You can obviously follow your structure, but the idea is to tag intentionally by knowing who are the end consumer that are going to get those costs to use. And you can also use special tags that you want. Let's say, for example, you have some resources which are customer specific, so you can use customer tags as well there, so that you can parse and get meaningful insights out of it. Now, all of these entities will be like in tags. The easiest way for separation, anyways, is not tags, it's by account. So if you can split the products, or if you can split your the AWS accounts into one for non-production, one for production, that basically makes the attribution a lot easier. Because it basically removes the need of excessive tagging. And also gives other cloud best practices like security and other things. Similarly, if you split it your account by product components or products, those which are disjoint in nature, then that's easier. But otherwise, if you are still left with mixed infrastructure, then the way to go forward is tagging extensively. And typically, you would want to, for a by design decentralized setup of cost optimization, you would want to put all the tagging inside your infrastructure as code, whether it could be Terraform or CloudFormation template or any of that, from where you know that it is never missed whenever a new resource is created. Now, we also touched about how to tie up cost with utilization, and that's something that is important for getting any meaningful insights out of it. This is one example where tagging may not be enough, where the AWS tagging might not be completely enough. Like for example, say for example, you are using something like a Kubernetes where there are like multiple services which are sharing a common Kubernetes deployment. Like for example, a service one for a product one, built by team one, and there's a service two product to team two, and their pods and containers, and they're running inside the Kubernetes cluster, which is shared. Now, tagging AWS resources are, though necessary, not sufficient to break it down at service level and then roll up at product one level. Now, this is where the philosophy of tagging changes from not just from infrastructure as code for creating the environments, but also infrastructure as code for managing the services. Now, the right way to do this is to um, roll up or use a shared tag, which is be put on your Kubernetes cluster, and you would have some way of monitoring the utilization through Prometheus or any paid monitoring tools, where you would tag at the pod levels, or using the pod levels. You would use a same common tagging principles to propagate the tag and maintain the tag which is outside AWS in your service definitions, through which you would essentially create those pod levels inside the Kubernetes cluster, and then use a shared tag to get the cost out of it from the AWS console. So now what you've done is that you've created a Kubernetes shared tag for, let's say, prod Kubernetes cluster. You have the shared cost out of it, you know the shared utilization, and then you can get a table which is service one, product one, team one, and you proportionate uh, the services, the utilization of that services by total utilization into the total cost. You can attribute to the service, and then you can roll up at product level or team level. Now, depending on your setup, hence the tagging has to be the principle of the hierarchy of the tags has to be maintained outside the AWS resource tags. And hence, wherever you can't attribute, or there are shared platforms which are sharing the same underlying platform, there you have to label it in some way to attribute the utilization and then proportionate to the shared cost tag. A similar concept goes for something like a EMR or Databricks, where this platform might be shared underlying with multiple service users in some sense, or users or services. And then you need to have some way of tagging, finding out the utilization, then proportionate to the actual utilization. Now we spoke about planning in the first conversation, where one of the examples that I took was, and one of the concept that we discussed there is creating anomalies and baselines. Right? So, let's look at how to create baselines and anomalies by simple AWS console tools. Let me introduce. I mean, this is something called AWS cost categories. I think most of you would know, but this really helps in creating anomalies and baseline tags per team. So when you are splitting the overall cost into different teams, every team needs to know their baseline and anomalies. And it's not just the baseline and anomalies which are only existing at the asset level, like the compute went up. But if we know that the compute went up, but only for this team is responsible, so you can narrow down your focus, and that team knows that my baseline cost has changed from this to this, and other teams are still unaffected. So essentially, what I'm talking about here is that when you break down your costs, there should be ways to also detect baseline and anomalies for each of the teams or product groups. Now, it's something called AWS cost categories, where you can create dimensions which are your business centric dimensions, which are not asset specific dimensions per se. For example, let's say your prod and your non-prod accounts are completely separate from each other, then you just can use the account dimensions to add it. But let's say there are machines which are running in the production, but for which there are probably not too many or not any customers at this point. It's the experimental product, and you probably want to attribute that to a tech budget rather than a sort of a business budget, right? So in that case, you might want to need to create a dimension which is a combination of all the machines which are running in a non-prod account, plus also some of the machines which are running on production account. So instead of doing it over and over again, what you can do is that you can create your custom business dimensions, which or through to which you can split your overall costs and use that dimension on any chart or any graph to detect anomalies and create baselines. Like for example, here there is a dimension group that I created called Prod Tech, which has different products of our own, as well as something like a tech here. So what I'm showing here is that you can just create rules for each of these dimensions and then add multiple rules here like tags. If it belongs to certain tag, if it belongs to certain account. So this will be classified as a tag, or if it is a different account, different labels, then I can use a different dimension value in it. So remember the tagging that we did earlier would be now used in this cost categories to break it down to some of your own team and product structure. Now this will be helpful if you obviously have share if you have shared tags, then this attribution might get a little complex, but you have account level separation, then it should work. But if you have shared tags between the products as well, then you probably need to just get the data out of the cost explorer or use the base AWS detailed line items to, and then tie it up with your utilization from Prometheus or Grafana to create the tooling yourself. So that's when you move from tools to tooling. But for simplicity purpose here, we will do, because our shared tags doesn't exist between products, different products, and it's only within the product. Then at least I'm being able to classify them, classify them with a cost category, which is at the overall product level. Now, once you create this, your structure specific dimensions, then the way to create baseline and anomalies is you can use simply AWS budgets. There's also a new tool called AWS anomaly detection, cost anomaly detection, which you can use to create. It is always used to use multiple tools to get signals, but here is something that you can use to, at least to some level, create baselines and anomalies for your teams. So you can just create. So AWS budgets is typically used for like setting budgets for teams, but we generally use it to create a baseline and anomalies per team, so that they know their baseline. So here I have used the same product tech cost categories, and I can put just the values here, and then create baselines. And again, when you create AWS budget, it is always good to sort of create baselines at different levels. So you can have maybe asset wise budgets first. So like for example, my Kubernetes cluster, this is the baseline. My S3 buckets are this baseline. My product and S3 combination is this baseline. And also you can use your cost categories here to also create baselines. So whenever an anomaly happens, that anomaly might be happening in a particular dimension, and this dimension may not be captured in a way. If you miss the dimension, then you might not be able to detect any anomalies in the system. So it may be a simple data transfer cost increase, which has led to something which maybe the anomaly happened in a particular product and particular sector only, or it can be across, right? So it is good to break it down both different asset-wise combinations, and also different business metric combinations. And also it is a good practice to also have a category which is unclassified in some sense, that I know these 5 services that I use, so I have set budgets for each of these, but I also set a budget for all the 30 services which are consuming pretty less, but tomorrow something else might come up there. So designing the dimensions and then creating the budgets across all levels helps you manage your budgets and cost categories. So here, for example, and for each of the budgets, then you can set your email alerts and things like that, which then can drive that decentralized governance where every team knows exactly what is happening. Whenever there is an anomaly is happening, they're catching it, fixing it, and you set up a process for your sustenance. We spoke about reservation planning earlier, and they give some examples, some tips here. Reservations on AWS specifically has have been of different types. Earlier there used to be machine reservations. Now there is something called a savings plan. Typically, when you think about a mental model of reservation, it is basically a combination of discounts, commitment, and optionality. Like say, for example, if you had no cost difference or no difference between a committed reserved instance versus on demand, you will always go for a on demand instance. If you want complete optionality in life, then the on demand is the best to go with, right? So because it allows you to shut it down at any point in time, and let's face it, there may be business changes in the future which might lead to uh, decrease in usage. There may be you might be able to figure out cost optimization strategies which you can reduce significantly in a quarter down the line. You'd probably go with if you want that optionality, you probably go with on demand. And if you want discounts really on the reservation, then and no and then you go for all upfront. If you want the maximum discount, obviously limits optionality. If you go for no upfront, again a little less optionality. But if you go for no upfront convertible, then you probably have some optionality for the future as well. On the amount that you committed, and then you have commitment durations 1 year and 3 years. When you go for 3 years, you get more discount. So this is essentially a trade-off between these three, and you need to know that what is your future cost and projections is going to look like, and based on that, you commit for 1 year or 3 years, and also at the same point in time, and not be too conservative as well, because otherwise you lose out on reservations which would probably be breaking even in 6 months or 9 months down the line. I'll quickly talk about savings plan, which is obviously a very new plan that AWS has launched. Earlier, you used to reserve machines. So remember the mental model we spoke about. If we know that our future consumption is going to go up, then we can go for a lot more aggressive reservations now, because it's going to give you some optionality in the future, because your consumption is going to go up. But if you feel that your reservations might get unutilized, then you go for more conservative reservations. And it is good to sort of bucket them into smaller chunks of reservations systematically, rather than doing one chunk, so that in a cycle you have more optionalities for the future. The savings plan came up with removed that machine reservations part of it, made it like how much dollar you want to commit based on the dollar, and you need to also do systematic reservations in savings plan as well. But here it is more simplified, going from actual machines to actually dollars per hour, which also applies to across regions. But would typically compare a savings plan 3 years would compare equivalent to a no upfront convertible reservation for the earlier reservation plan. Now, there are a few things to note here, and there is one trick that I want to show it to you, is that what AWS algorithms essentially does is that it takes that dollar per hour, and for every hour of that day or that committed period, it applies that dollar to the highest discount machines, right? So what it does is that all the machines that are running for that hour, it will take the highest discount and apply that first, then the next one, then the next one, until that bucket is filled up. So think of you're carrying a bucket, you're collecting objects, you're compressing them and probably putting it there, and you're applying to the ones that has the most discount. So that's how the algorithm works. But what it also means that your returns decreases with more commitment. For every dollar that you add, you're probably going to have the same discount or less on this, right? So when you are and discounts are based on machine types and operating systems and things like that. So essentially, when you're thinking of optionality, it is all about how much I'm committing today, how much of returns I'm getting, and where do I break even, right? So so in terms of the ones that have obviously are the highest discount, makes sense to reserve. But obviously you're committed only the dollars. Now this return, so there's a if you define a formula which is return on commitment, it's slightly different from discounts, which is expected discounts per dollar of commitment. So you have, if you add $1 bucket, then $2 bucket, $3 bucket, and then your returns or the return is always positive, but the return percentage is basically decreasing, right? It can go down. If the machine has about 50% discount, then your return is about 100%. Our ROC is about 100%, and it can come down to machines like Windows machines are much less, like 25%. So you might go up to like 14, 15% or 16% ROC as well. So the way to look at this is that if you add more dollars, your ROC goes down. So at some point in time, depending on the previous slide where we talked about optionality, discounts, and commitment duration, you can see how much of appetite you have to reserve, and then at what ROC point that you want to stop adding more dollars to the bucket. An example of that is here. Generally, savings plan comes up with a savings plan recommendation, which computes savings plan recommendation, where they give certain recommendations, but it's very important to rationalize that as well. Like for example, when I look at this, what it has recommended is a 3-year reservation, no upfront. About $10 if I commit, I get about 14% average returns on this. Now, you might ask yourself that if savings plans is advertising to have more than 50, 60%, 80% reservation, why it is only 14%? So this is just a number that has been given by AWS recommendation engine. Can we rationalize this? So the way to rationalize this is to go to the cost explorer and then enable hourly reports, which can give you the hourly report for the last 14 days. And this is the same duration that I've chosen here as well for the recommender to calculate. Now, this is the pattern that I see here. So this is, I've chosen issue to instances, removed all the credits, removed, added only the purchase option on demand. So this is the residual on demand. All the on demand that is captured in savings plan or spot, and all of that is filtered out. This is only the residual on demand per hour, which is basically is further analyzed in the recommender engine for giving the recommendations. Now here you look at the variations that is happening every day because of auto scaling and things like that. And then you choose like how much you want to reserve. You want to reserve only the base of it, or do you want to reserve some a fraction of that? I would not recommend to reserve the minimum reservations here, because then your reservations will go unutilized for some durations. But also you can do more things here. So if I actually break it down, this on-demand, the residual on-demand instance of platforms and things like that, we'll actually find more Windows machines and things like that, which is residual, which is not being used by a savings plan because the discounts are less on top of it, which is basically what is leading to this lesser percentage that is being realized here. So again, so now having this from this one number that you had, you can actually now go into and figure out what is really left out for reservation. Do I need those machines? How much discounts on this have? And even that, the ROC will still keep decreasing. So you can find out exactly at what point in time you stop and make that reservation. So AWS till now has not provided a sort of a breakdown of this recommendation. So you can use Cost Explorer, rationalize this, tally these numbers together, and then come up with a number which can give you the residual savings plans. Now, in the systematic savings plan, where I spoke about every 3 months go and reserve something, and then something is expiring and something you're reserving, that point in time, you can look at this graph and figure out how much really I want to go ahead and reserve. So this is a setup about reservations. Now, a few concluding slides on different types of workloads. What we've seen, working for optimizing cost for different types of workloads. Real-time systems. Obviously, if you are stateless, systems cloud ready, then use Spot, and you can pin the minimum workload that is required. Let's say one of your APIs requires 10 instances, then you can put some in on demand, but rest you can put on Spot. So that scheduling helps in terms of optimizing cost if they're stateless. Stateless systems always help in cost optimization. Auto scaling for many of you would be from the for e-commerce, and where the traffic can really change significantly, and on auto scaling really helps to keep the cost down, rather than going and scheduling for scaling. Stateful set, you might have stateful set as well, which would be which would which might cause disruptions or might require time to reboot and things like that, where you probably better idea to pin them to on demand and then consider reservations for them. Measuring disk utilization is definitely one of the things that has helped us quite a bit. We use Aurora. We started noticing IO variations which are causing cost spikes, and we figured out there are certain queries which they run, they're causing more IO, and they're getting fired much more um, often. So measuring disk IO utilization as well as the parts are also you can use in real-time systems. Sometimes the disks that are attached to machines, because real-time system has more or less a fixed pattern of APIs hitting your platform. Sometimes they might be really over provisioned, and you need to also measure that how much of IOPS you really need and how much of the IOPS that you are really paying for. And if it is HA, then you have to be conscious about the inter-AZ transfers, also latency. There are many architectures which have evolved. You could obviously, if your inter-AZ transfer is less, then it's a very simple load balancing that you can do across AZs. But there are also architectures which have evolved where you have a top level distribution, and the one system on one AZ and the other system on other AZ are just complementing each other, and the top level routing is happening between them. So every system is replicated from one to the other. So that's also another way to consider. So there are many of these architectures which are evolved, and the key takeaway would be to make the real-time system or the APIs and other things as much as possible stateless. It helps in terms of recovery and also helps in terms of cost. Then there are batch workloads, like in Capillary we use ETL for nightly computing our KPIs. We can create a incremental data warehouse every day. And there you can use Spot heavily, but with fallback, because it is time bound. So understanding the nature of the workload is important. So this is a workload which has to finish in few hours. It doesn't, if there are terminations, it's okay, it can recover, but it needs to have a time bound execution. So you do a time bound scheduling, look at that, how much time is left, and based on that decide whether we want to use Spot or on demand, and how fast we want to do it, and always have fallbacks there to on demand nodes, so that job completes on time, but can use Spot very effectively. Some of the systems like Spark or Hive and some of that are also pretty much AMI heavy, because you need to pack a lot of AMIs for that system to, or that cluster to run. So when you want to use multiple machines types, multiple generation of machine types, like for example, 5th generation, 4th generation, Graviton, or maybe some GPU instances and things like that, it's very cumbersome to pack them on your own, each type of the workload. So it's best to use a managed service like a EMR or Databricks. They provide the machine base AMI packings very well. So you can use various of the machines in your Spot fleet, and your batch workloads will perform better cost optimally. Multiple instance options, as I spoke about, generally memory heavy, could really benefit. And some of these batch workloads also might be storage heavy. So using storage tiers are going to give you some of the cost optimization benefits, like on S3 tiering for persistent. If you're processing, say, logs and things like that, then when to zip it, when to move it, when to use in different storage layers based on the criticality of the data. You would want to create storage tiers to store large amounts of data, particularly if you're a data-driven company. Then the last one would be, want to touch upon some of the ML workloads, maybe mostly around training, obviously inferencing and other things where you have to be much more, the availability matters much more. But in, let's say, you're doing trainings and things like that, or you're experimenting on certain things, then Spot can be used heavily, and you could just run on Spot always, because there's no particularly a time bound. Again, depends on your domain and all of that. But what we've seen is that some of the historical data training and all of that you can use extensively on Spot. Again, managed systems are a lot better because you need to pack a lot of the things to the AMIs, and creating a managed system or having a managed system utilization better, and you can build tooling on top. Yeah, so multiple instance options, not always entirely applicable here, because sometimes they can be really CPU hungry, so you need to choose a certain type of workloads only. But leveraging Spot, leveraging time of the day to choose to run some of these workloads where that the maximum Spot availability is there, and using managed system really helps. These are the three types of workloads, and how do you use some of the cost optimization techniques in practice. Thank you all, and look into some questions now. You can reach me on email, LinkedIn, and Twitter if you have any further questions. Thank you. Thanks a lot.
Thanks, Pravanjan. Folks, I hope that gave you some insights into how to leverage the AWS tools to analyze your costs, dissect them into different categories, and run your optimization processes on that. One observation I had, Pravanjan, you touched upon the inter-AZ transfer costs, right? Again, this is also linked to the data transfer costs we had. We would be discussing in detail in a few minutes from now. But what has been your experience in inter-AZ costs actually?
Yeah, so inter-AZ costs are like, this is one of the, again, very leaking sort of a bucket. So it essentially, what happens is that you have to, in your architecture, you have to identify how your HA workload is essentially running. So let's say your services are distributed across AZs, but your database is, let's say, residing on a third AZ, right? Now it all depends. It may be a good architecture as well if the data transfer is not too bad, because at any point in time you have a better availability. But it may be also bad because if your data transfer costs between services and the databases are very high. So it depends. So essentially, some of the best practices here could be that, let's say your service architecture is, let's say, has a, so like I was saying, that your services can be inter-AZ, and then your, let's say, for example, your Redis and some of that. If a HA is possible on that, you ideally would want to place them closer to the services, so that you don't incur the intra-AZ costs. But this overhead is only, you go into this much of complexity only if you find that your data transfer inter-AZ is high. There is also things like in our ETL process, when we scoop a lot of data from our databases, different data stores, into a common HDFS, and then process from there. There also we take care of that the databases and the Spark cluster that runs are on the same AZ, so that the data transfer costs are minimized on that front.
Got it. Great. So we touched upon the savings plan, Pravanjan. So Nandish and Ramcharan, just wanted to hear from you, how has your experience been from the savings plan? Reason being, when I first came across savings plan, I was like, okay, this is like a math or a science in itself. It takes a lot of like understanding, and I'm not sure if many folks of you remember, right? So when AWS computes your invoice, right, you have the savings plan, you have the reserved instances, you have the on-demand instances. I somehow felt, it applies some kind of a bin packing algorithm of figuring out, okay, how much I knock off from where. On the first glance, it seems they're trying to give you the discount, but actually they're trying to maximize their billing. I don't know. Like, what has been your experience, Nandish, Ramcharan, on this?
Yeah, I mean, it's true that it's complex, right? So we have a team working just on some of these aspects to analyze the data and then work with the vendor. I would actually say it is more around looking at the data, making sure that we are very clear about the from and to state in terms of going into a savings option on certain things. We do have few cases where we know that we are going to incur cost on certain resources, and we know that it's going to get expanded due to the business nature. There we look at what would it take if we go with the existing option of commitment versus the option that Pravanjan talked about, let's say 1 to 3 year commitment as an example, right? So those options, I think it's case to case basis, but I think some of these calculations will actually help us to get there. I would say data is the only thing that can really help us here, and it will certainly vary based on organization and the volume that you deal with. I would say that it has certainly helped us save cost a lot, specifically on some of the high volume data transfer cost as well as the resource utilization cost, specifically on the EMR, SageMakers, and some of these things as well.
Got it. Great. So, yeah, go on.
Sorry. I don't have much to add on the savings plan because it involves upfront commitment, and we are not for upfront commitment anywhere. So
yeah,
I have no say on the savings plan unless I mean we come from the poor background, so no comments on that.
Got it. Folks, by the way, from what I know, GCP also has something similar to savings plan. I'm not sure about Azure, Ali, and the other clouds, but yeah, I mean, if someone knows about it, do share your thoughts on the chat section. Right? I think we also touched upon the topic of tagging, which I'm hoping Sunil, Vikram, your questions were answered. If not, please again raise your questions or reach out to any of the speakers one-on-one. Yeah, and I think there was also a question.
Pravanjan, do you want me to repeat the question?
No. So yeah, so you were asking that how do you manage the data transfer cost when talking about multiple case clusters? So I think I would say that I would go from the other angle. I would first capture the application intent. So if the application intent is, like for example, point redemption for us, it has to be highly available, or it is a commerce transaction, right? So in that case, it has to be like cross AZ. So it doesn't matter what the data transfer cost is. Obviously, you have to measure it. But if there are services and the associated databases which can really recover a failure, let's say, for example, we are sending out a campaign, probably one restart is fine, outbound. So in that case, those services will be preferred to pin it to a particular region, so that the dependency of that service and associated ones are limited to a particular region. So we definitely prefer one region. So if you look at our workload, you will see 90% of the workload actually belongs to one region, and couple of workloads are across regions. So that's how we do it to balance between HA and inter-AZ, and also like minimize cost. But having said that, our data transfer cost has not been like a prime dominant sort of a problem for us. We have encountered anomalies for sure in data transfer, but our baseline has been lower. So whenever we found data anomalies in data transfer, those are particularly because somebody else has done something really funny. But otherwise, our data transfer is not much. But for somebody like you, it will be like really significant because you deal with content and things like that. So would want to know from you, from your talk, Ram.